Okay, then the comparative half-lives and forbidden decays. Beta decay half-lives encompass an enormous range from the order of milliseconds to about 10 power 16 years. Part of this variation must be due to the poor matchup of the initial and final nuclear wave functions. But it is hard to imagine that nuclear wave functions are so purely one configuration or another that this effect can account for any but a relatively small part of this variation of 26 orders of magnitude. The true source of the variation in half-lives is the relative difficulty of creating a beta particle and a neutrino in an angular momentum state with L greater than 0. Neutrino physics: a process closely related to beta decay is capture of neutrino or an antineutrino by a nucleon. Antineutrino plus proton gives neutron plus beta plus E plus positron. Neutrino plus neutron gives proton plus electron, which sometimes called inverse beta decay. This process sometimes called inverse beta decay. Let's first discuss why only this process occur and not others such as capture of neutrino by a proton or of an antineutrino by a neutron. Electrons and neutrinos belong to a class of particles called leptons. നമ്മൾ ഇവിടെ നിങ്ങളുടെ പുതിയ ഒരു കാര്യങ്ങളാണ് ഡിസ്കസ് ചെയ്യുന്നത്. Okay. The antiparticles E plus and nu bar are anti-leptons. Okay. അപ്പോൾ leptons എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ electrons and neutrinos. Leptons. The antiparticles positron and antineutrino are anti-leptons. Based on observations of many processes and failure to observe certain others, the law of lepton conservation is deduced. The total number of leptons minus anti-leptons on each side of a decay or reaction process must be same. Conservation of lepton number എന്ന് പറയുന്നത്. Many sensitive searches have been made to find violation of this law, but none have yet been found. The reaction nu plus p neutron proton to and neutrino plus proton to neutron plus positron, which conserve electric charge and nucleon number, does not conserve lepton number and is therefore, according to our present understanding of fundamental process, absolutely forbidden. Neutrino chargeless, positive charge, chargeless, positive charge. Charges conserve ചെയ്തു പക്ഷെ lepton number conserve ചെയ്തിട്ടില്ല. അതുകൊണ്ട് this process is forbidden. The failure to observe such reactions is in fact one of our best indicators that neutrino and antineutrino are really different particles. The electron and positron differ in the sign of their electric charge, but neutrino and antineutrino are uncharged. They are thus immune from the electromagnetic interaction, which is often used to distinguish particles from antiparticles. The resulting cross-section, scattering cross-section, is sigma equal to 2 pi by h cross g square by v square m fi square 4 pi p square dp square by h cube dp by de v by c by v. Using dp by de equal to e by c square p gives sigma equal to 2 pi by h cross c g square mfi square 4 pi p e by c square h. Putting all the numerical factors, the resulting cross section is calculated as 1.2 into 10 power minus 19 bar, which is equal to 1.2 into 10 power minus 43 cm square. We can appreciate this incredibly small cross section minus 43 by evaluating the probability for a neutrino to be captured in passing through a typical solid, which contains of the order of 10 power 24 protons per cm. The neutrino has a reaction cross section of about 10 power minus 43 cm square for each proton it encounters, and in passing through 1 cm cube of material, a neutrino will encounter about 10 power 24 protons. The net reaction probability is cross section into number of protons give 10 power minus 19 per centimeter. That is, the reaction probability is about 10 power minus 19 for each cm of material through which the neutrino passes, is very much less, right? Less than 1. To have a reasonable probability to be captured, the neutrino must pass through about 10 power 19 cm of material, or about 10 light years. So that is why it took a longer years to discover the neutrinos. We are thus resolved to the fact that neutrino and antineutrino are different particles, but we have not yet specified just what is the fundamental property that distinguishes neutrino from antineutrino. Experimentally, there is one property. All antineutrino have their spin vectors parallel to their momentum vectors, while neutrino have spin opposite to momentum. Then antineutrino-neutrino difference. This property is called the helicity and is defined to be helicity H equal to S dot P by modulus S dot P, which has the value of +1 for antineutrino and -1 for neutrino. That is, helicity for antineutrino is +1 and for neutrino is -1. It is often said that antineutrino is right-handed and neutrino is left-handed because the precision of S about P traces out a pattern analogous to the threads of a right-handed screw for antineutrino and of a left-handed screw for neutrino. Okay, thank you very much.